Oops, sorry.
Plus b squared equals c squared. That's the only thing, by the way, that I teach that people shout out confidently. Anything else, people are like, a squared plus, no. Everyone knows a squared plus b squared. Is it frozen? No, okay, equals c squared. And we don't really care which is a and b, but we care about c. C has to be what? So sometimes in the formula you'll see h squared. Okay, so don't panic if you ever see a squared plus b squared is h squared, h being the hypotenuse. 6 can be a, why not? B, be careful with the brackets that you're bracketing your -3 because of the negative, otherwise it's wrong. And we don't know what either c squared or h squared is. 6 squared?
36.
-3 squared? Now I heard positive and -9. Let's talk about why it's positive. -3 times -3, negative times negative equals. Why? Why does a negative times a negative equal a positive? But why?
Because negatives cancel each other.
Why? Okay, so I'm going to say a sentence in English, and this is probably going to sound wrong to you if you're English speaking, maybe not if you're not. I didn't eat no bananas. I didn't eat no bananas. Like, so that should sound wrong. You're like, something's not wrong there. What's wrong with that? Double negative, right in English. We're like, haha, double negative cancels out. So if I didn't eat no bananas, what does that really mean?
You ate bananas.
It's the same thing in math. Double negative cancels out to be positive. I digress. Yes.
So, but like,
Yes.
people say like, I need no bananas. They mean like.
That's like bad. That's bad grammar. Yeah. Yeah, it's bad. From the hood. Yes, from the hood. Yeah. BEDMAS says we add, so 36 plus 9. How do we get rid of a squared? What's the opposite of squaring something? So h equals square root of 45. Oh, but wait! Remember grade 10 with radicals, and you have to simplify radicals? Remember that? And so we got to think, what are the factors of 45 that's a perfect square? So we're like, 1 times 45? No. 2 times? Nothing. 3 times? 15? No. Oh. 9 and 5. So then we break this up into 9 times 5. And then we break this up into root of 9 times root of 5. Remember all this? And then we say this is 3 root 5. Remember that from grade 10? That was grade 10, yeah. Positive, unit 3. Oh, well, we talked about it again last year, but you first learned it in grade 10. Remember that? Now, we do not, never, just kidding, we do not grab our calculator and get the decimal value. I don't care what 3 times root 5 is as a decimal. Why do I not care? Because the question said exact value, so that means no touching the calculator. And what that does is it turns it from a calculator question to a non-calc, because there's nothing in here we've used a calc for. Now, what the question is asking for is give the fractions for sine, the fractions for cos, and the fraction for tan. That's what it wants to know, or what are those 3 ratios, we call them. And so I know sine is O over H from way back in grade 10, and cos is A over H, and tan is O over A. And so now I'm just substituting right from the triangle. What is the value of O in my triangle?
6.
And what's the value of H that we just calculated?
3 root 5.
And can I simplify that at all? Can I make that smaller? The 3 and the 6 we don't like because we can reduce them both by 3. So if we reduce them both by 3, we get 2 over root 5. But wait! Remember radicals, grade 11, unit 2. Remember this thing about the roots on the bottom? And remember we're like, no, we can't stand roots on the bottom. We don't care in grade 12.
Thank you.
As a mathematician, I care. This bothers me. It gives me the heebie-jeebies, like it just makes me tick a little bit. But the theory behind it is that was a grade 11 concept, and we don't want to penalize you in grade 12 if you don't understand it. So you are allowed to leave roots on the bottom. There's times I will, and there's times I won't, and I'll tell you why at that time I am or I am not. So I'm going to leave it, even though it bothers me personally. Questions so far?
What if we did rationalize?
If you do it correctly, that's okay. If you make a mistake, then we have to start taking off marks. Cos A over H. What's the A value from the triangle? -3. And what's the H value? It suddenly got really quiet. 3√5. And can I simplify those at all? I can cancel the 3's. And so, okay, -1 over, and again, if you want to rationalize that, I would because I'm a mathematician, but I will just let go of that. And what's the opposite from the triangle? And what's the adjacent from our triangle? And can we reduce those? I heard -2. This is what the first example is asking you for. That is the exact values as sine cos tan for the angle formed between joining the line segment from the point 3, -6,3 to the origin. Why do we need to know that? I will tell you tomorrow. I know you won't be able to sleep now. It's okay. You can watch my videos. They help.
Do you delete your old videos?
I haven't yet.
Like all, like from last year?
Yeah, you could watch this all from last year if you wanted to.
Oh, sweet.
Questions so far?
Looking down to the line.
Questions? 2, 3, 4 are really what I want you to remember from last year. One was just putting the idea of sine cos tan back in your head. So I call this, given one trig function, find another. Because, for example, in 2, they say find sine if tan is 3, and then there's some crap in brackets after. Number 3 says find sine if cos is this, and then some stuff. And then 4's got more words. We'll worry about that when we get there. So this is really what I need you to remember from grade 12. Grade 11, I mean. How are we doing so far? I will come back to the method box. I'm just not there yet. So example number 2. They have given us that tan is 3. They've given us this stuff here in brackets. And they're asking us what is sine. What they're really giving us with tan there is they're giving us two sides of the triangle. So rather than giving us a point like they did in example 3, they're giving us two sides that's just a little bit hidden. What do you know about the formula for tan? It is opposite over adjacent. That tells us automatically that the opposite side is 3. And although I don't see it, what do we know about the adjacent side? It's 1. So it's the same thing as giving us a point. They're just hiding it in tan, but they're giving us the opposite and the adjacent. We want to know sine. Well, what two sides do we know to give sine? We need O and we need H. I got O. That's 3. It's right from the question from tan. What do we not have? Hypotenuse. Well, we didn't have it in the last example. How did we find it then? Pythagorean theorem. So I know that O squared plus A squared equals H squared. Look what I did there. If you want to call them A and B and C, go for it. So O is 3. A is our imaginary 1. H we don't know. 3 squared? 1 squared? 9 plus 1? How do we get rid of a squared? What's the opposite of squaring something? So H equals root of 10. Can we simplify?
Nope.
So we check the factors. 1 times 10. Is there a perfect square there? 1, but that's not going to change. 2 and 5. Are either of those perfect squares? No, so we're done. Root of 10. So that means I can come over here to sine, and I already know the bottom. What's the H value? Root of 10. It's the same question as above. They've just hidden the point information. They haven't blatantly said, here's your point. But wait. We got to worry about this crap that was in brackets behind here. That's a cast rule thing. Turn and talk to someone. Tell them what you remember about the cast rule. I'm hearing lots of memories coming back. This is awesome. So last year we brought you into this whole idea about how for every single angle there's two sines that have this, two SINEs that have the same sign, two cos values that have the same sign, two tan values that have the same sign, and the cast rule, and how your calculator is dumb, and when you use your calculator it only gives you one of the answers and you have to remember all that? Okay, so this is actually just a mnemonic. It's just a memory device to help you remember where things are positive and negative. What does A mean? So it means in quadrant 1, sine, cos, and tan are always positive. What does S mean? Sine is positive, but cos and tan are negative. What does T mean? Tan is positive, inferring that sine and cos are negative. C stands for cos is positive, therefore. Okay, remember all that? So because of this stuff here, we have to maybe do something down here. This is telling you that tan can be in any 4 of the quadrants. It can go from 0 all the way to 2 pi. You would have seen this last year, but it would have said 0 to 360. Why does it suddenly say 2 pi now? Because you know about radians. So last year we would have said 0 to 360. That means all the way around the circle, tan can be anything. So because it's positive, what quadrants might this be in? It might be in 1 and it might be in 3. And I'm going to put a plus sign in front of the 3 just to show you that's how we knew, because it's positive. The difference from example 1 is we knew what coordinate the point was in. We knew it was in Q2 if we look at the picture. Here, we don't know. This might be Q1, it might be Q3, we don't know. So we need to account for both of those. In quadrant 1, sine is positive, but in quadrant 3, sine is negative. So is this the only answer? No. What do we need to put in front? Plus or minus. That's what the cast rule does. Kind of coming back from last year? I'm going to go to the method box, and for the wordy peeps, we'll get some methods down. Step number 1, label the sides for the given function. Label the sides for the given function. Oh, thank you. Label the sides for the given function. Step number 2, calculate the missing side. Calculate the missing side. And that's always going to be an a squared plus b squared equals c squared thing. If you think you might forget, you might want to add in an extra step here that says simplify the answer if necessary, or simplify the radical, or check the radical, whatever makes sense to you. So if you think you might forget that, this is where you're going to simplify the radical if you can. Write the formula for the wanted side. For the wanted function. Substitute into the formula. Substitute into the formula. This is where you would reduce if you can. And the very last step, check the cast rule. For substitute into the formula, and I added if you want, this is where you'd reduce, so reduce if necessary, reduce if you want to, whatever. I'm going to go back to the last example, and I'm going to label where we did all of the steps. Oh, sorry, check the cast rule. So this is where we did step number 1. We labeled that tan is O over A. Step 2 was here, which was calculating the H value. Step 3 was writing the formula for sine. Step 4 was substituting in. And 5 was figuring out that we needed the plus minus. And if you're a bit iffy on step 5, it's okay. We're going to do 2 more examples. Show me a thumb so far. Getting it, kind of getting it, not getting it, wherever in between you happen to be. Good. Now, if you're on the side, I'm okay with that right now. Okay, example number 3. You don't need to write that stuff. It's just my brain likes to summarize a question. It's just how we work. If you don't need that, don't write it. Step number 1. We want to label the sides for the given function. What's the given function in this question? Cos. Label the sides. Cos is what over what? But what are the sides of the triangle they correspond to? A and H. That means we need to find O. Okay? So O squared plus A squared equals H squared. If you prefer A squared plus B squared equals C squared, use it. Nothing wrong with that. O we don't know. A we have as -2. Watch your brackets there. And H is 5. O squared plus -2 squared is? Audience participation welcome. 5 squared? This is just an equation. We're going to solve it like we solve all equations. What's the opposite of adding 4? Subtract 4, so O squared equals 21, I heard. How do you get rid of a squared? What's the opposite of squaring something? So O equals root of 21. Simplify. 1 times 21, 7 times 3. Anything in there? No, there's step number 2. Step number 3 is we're going to write the formula for the wanted side. We want to find sine. So sine theta is what over what? What's the formula? Opposite over hypotenuse. Step 4, plug them in. O is root 21. H is 5. Now we got to do the cast rule thing. We start with the given function and we look at its sign, whether it's positive or negative. Cos, negative. What quadrants does that tell you? Cos, negative. Quadrants 2 and 4, I heard someone say. Then we just check the interval and we make sure those are both in the given interval. What does this mean? Well, it means you can go from 0 all the way to 3 pi on 2. Are both of those quadrants in that range? So look at the circle. I was waiting for someone to correct it. And because I'm left-brained, I have to white out. There's no scribbling in our world. Are we happy now with 2 and 3? Yes. Awesome. Now we just check the interval given in the question, and that says 0 all the way to 3 pi on 2. Are both of these okay? Are they both in this interval? Yep, so now we go down to sine. And we say in quadrant 2, sine is positive, but in quadrant 3 it is. So I got to put a plus or minus in front. Okay. Cast rule says because cos is negative, it could be 2 or 3. This is the secondary rule because sometimes they'll limit you here from 1 to 2 or they'll limit certain quadrants. This notation means from 0 all the way to 3 pi on 2, which means these are both good quadrants. Cos is negative in quadrant 2, but sine is positive. And in quadrant 3, it's negative. So I need both the values here because of these two quadrants. Number 4, by yourselves, with a friend, with me. Thoughts? By yourselves? Okay. We'll talk in a few minutes. O over H. Step 2, find the missing side. What's missing? So 1 squared plus a squared equals 4 squared. If you jumped right to this step, I am A-okay with that. So I will show you along the way where you can skip steps and where you can't. 1 squared and 4 squared, so 1 squared is, and 4 squared is. So if you go straight to a squared equals, I am A-okay with that. A therefore equals? Can we simplify? Can't touch it. Step number 3. And what's the formula? Step 4?
Plot in that, because you know A, so you get to plot into the equation itself.
Step 5?
Cast rule.
Okay, so quadrants here because of sine. 1 and 2. Are they both in this interval here? Are they between 0 and 2 pi? Yeah. So then we need to come over here. Quadrant 1, tan is. But in quadrant 2, listen. I'm not going to talk to you as your math teacher. I'm going to talk to you just as Joe Schmo right now. If you have no idea how to do that on the exam, put positive, negative, because it's the most common answer that comes up. I'm not saying put that all the time. I'm saying if you are in exam panic and you are stuck, just put down plus or minus. It's going to get you more marks than if you don't. Questions? Kahoot!